The Saudi Arabian government is offering top academics on the order of $1 million to fly out there. And more importantly, I mean, you get to create your own lab. We're going to make it really easy for you to just come out here and have all the compute you want. And we'll be able to, in 10, 15 years, create our own little version of Silicon Valley in Saudi Arabia.
Patterns break the code, pre-trained pod.
And welcome back to the Pretrain Pod. I'm Pierce Freeman, AI founder based in San Francisco, and I've built and sold multiple AI startups.
Hey guys, my name is Rich. I'm a AI research fellow at the University of Cambridge.
Richard, it's great to see you. Happy early Thanksgiving. We're recording this on Wednesday, day before Turkey Day for those who celebrate in the States. I just love Thanksgiving. I feel like it's such a great excuse to just bring people together. You see your family. It's actually a very wholesome holiday, at least in the modern incarnation. I feel like it's
100%.
kind of questionable.
Yeah, back in the day, probably not as
Yeah.
wholesome. No, it is pretty cute.
Yeah, certainly not the vibe. But, it's great. My only knock on it is I hate turkey, and I never will eat it for the holidays.
Turkey?
I really don't like turkey. Do you like turkey?
Really? I feel about turkey as I do about English breakfast tea. You know what I mean? It's like, sure, dude, if you've made me a batch of English breakfast and you're having some, I'll have some too. I don't really care. Am I going to make myself this thing? No. Like, why would I? I'll just make myself a coffee.
Yeah, sure. I feel like everyone has their secret to making turkey not dry. It's like people have the family recipe.
Yeah, what's up
different
with that?
preparation style. People are deep frying turkeys to try to
Right.
make them not dry. As guys, at the end of the day, the thing just wants to be dry. You're
thing that
you're
just
literally
sucks.
fighting its
Right.
natural inclination to be dry.
Right,
Pick
right,
something
right.
that doesn't get dry. Pick a chicken.
That's true,
Pick
dude.
a salmon.
Just pick chicken. It's true.
You
It's
pick
true.
every other meat doesn't get dry. It's just turkey. Well, Richard, in addition to being a week of Thanksgiving, a week of bounty, it's also been a week of bounty in the ML model scene. I feel like just about every frontier lab released a new architecture this week. So we're going to talk all about them. Specifically, we're going to be talking about OpenAI's new compression mode, Gemini 3.0, and the new Nano Banana Pro, Nvidia chip exports internationally, and what the latest Cloudflare outage can tell us as a cautionary tale for AI deployments. You want to get started?
That one sucked, dude. Let's do it.
So, Rich, this was a week where I feel like we just battled the sweet bench scores into absolute oblivion. First out of the gate was Gemini. They got a soda. Then OpenAI followed the next day with GPT 5.1 Codex Max. I really feel like they have to start rebranding these to have a little bit more consistency. And then Anthropic released 4.5 a few days later. Honestly, I feel like by the benchmarks, they're all pretty similar models, at least within the same weight class of performance on things that people care about, like tool calling, long-term reasoning, and coding ability. So I thought it might be more interesting, instead of just trying to recap the benchmarks, which people can find online if they're curious, try to break down what are actually the unique qualities of the different models. So I'm thinking maybe we could start with OpenAI's new context compression mode that lets an autonomous AI coding agent run for up to 24 hours within one session. So you give it one text prompt and it can take that and, in theory, go off for up to 24 hours of continuous processing. I was thinking maybe we started talking about how other coding agents have done things up until now, and then how we imagine OpenAI's approach here is actually working under the hood.
I mean, these things have been happening behind the scenes for a long time. I just haven't become aware of them until recently. In Cursor, if you're using any model, if you've been using a model on Cursor for the last year, you'll notice that you can actually pretty much use that model for days without having to refresh the context window. Because what happens is, as soon as it gets to close to filling the context window, and you can see this in Cursor, there's a little icon that shows you how close you are to filling the window. So as soon as you get to 95% full context window, you'll see the application basically start buffering a little bit. It'll say, just hold on a second. And then what's happening behind the scenes is it summarizes your previous chat history and then plugs that into basically a new, fresh chat history, and then goes from there, but without you really ever realizing what's going on behind the scenes. Like, you never had to click on create new chat. So it's interesting that Cursor and these wrappers around LLMs have been doing this for a while. This is interesting because I think for the first time, you could call this native context compression that they're doing here. Like, they're building it into the model so that folks like Cursor don't actually have to do this as a wrapper around the model. And I think that makes a lot of sense. I could see that being a feature of all LLMs going forward. It's almost surprising that this isn't something built into things like Opus or, Grok
Yeah, or
or
Claude Code.
Gemini.
I think it really just shows how organically all of these things have been evolving. Where the labs, one engineer, one researcher at the labs will have some idea, try something, push it out, and then people will really start using it and it seems useful. I mean, that is the whole origin story of Claude Code. The thing that really launched this agentic revolution of people using terminals to do coding in this autonomous loop. It was just an internal project that they were using internally and said, hey, this is pretty useful. This is helping our engineers work on our web app a little bit faster. Let's push this out and make it public. And then it just absolutely skyrocketed in adoption. What we know about Claude Code, in addition to Cursor, is that the compression that it's doing is just super naive. I mean, we can actually look at the API calls that it's doing in order to do this compression. It's taking the entire chat history that you've had up to that point, all the tool calls, all the outputs, all of your inputs, feeding that into the same exact architecture model. So if you're talking to Sonnet 4.5, it's also feeding that context window into Sonnet 4.5. And then it's just asking Sonnet 4.5 politely to summarize what you've said into maybe a couple of paragraphs.
Pretty,
Yeah. Please, Yeah. And I'm sure they've calibrated that system prompt over time a little bit to say, if you seem to be working in one file really continuously, we should probably include that path within the system prompt. Or if you switched gears and you're working on something new now, but you started the conversation doing something else, let's just focus on the thing that's new so that you can continue with what you're currently doing. I'm sure that they have some heuristics in place to try to guide the summarization model to focus on that instead of trying to focus on other parts of the context window that aren't going to be as relevant. But it's a pure text summarization model. And then you're taking that text summary and then you're feeding that into the next conversation as the initial message, as if you have written that yourself, which I feel like works relatively well in practice, but it means that anything that's not in that summarization content is just going to be completely missing from the new knowledge that your second conversation has done. No matter how transparent you make the UX, you're literally making a new conversation, right?
And in addition to that, your experience using these models, say that you're starting using, Sonnet 4.5, your experience with Sonnet 4.5 won't just be impacted by Sonnet 4.5's ability to solve coding tasks if you're using it in Cursor. It'll also be impacted by Sonnet's ability to summarize itself, basically. Like, how good is it at compressing its own context, right? Because I've noticed that actually the models that I get the most kick out of are the ones where I very rarely create a new chat window, where I can just in Cursor just keep typing away and it feels effortless because I just, behind the scenes, all this compression stuff is happening. But that only works because these models, as you said, are basically summarizing their own context history. So not only do these models have to be good at coding, they also have to be good at this like meta task of self-summarization, which I think is interesting. So yeah, I think it's strange to me that we haven't really created models that are just specifically good at summarizing context history, or that we don't use this as part of Cursor. Like, it would make sense if these two things are separate, right? Like the ability of the model to solve coding tasks and the ability to summarize. For all intents and purposes, like those could be two separate models.
Yeah, it's a good point. And I think maybe that's what OpenAI is starting to do here. I think from what little we know about actually how they're implementing this behind the scenes, my guess is it's still a text-based summarization approach that they're doing, in part because the architecture that's going to host this Codex generation of models is probably the same architecture that's hosting the regular ChatGPT models, just with like slightly a fine-tuning set of weights applied to it. So
you don't think they're doing like any like attention syncing stuff, or like a prefix tuning thing where you
honestly
learn a context vector?
No, but I think that's worth talking about as like extension approaches and possible things that they might be doing behind the scenes. But my guess of what they're doing is that instead of just using a human written prompt to try to encourage the model to summarize a conversation history, I think just within the RL environment that they're training on and then backpropping the reward function in this RL environment, they're encouraging the model to continue the conversation past its window, forcing it to generate one of these summary documents and then piping that through another session. And then that whole thing becomes what the reward function is evaluated against. Versus typically reward functions are kind of this like one-shot behavior a little bit more, where you have some turn in the conversation and then you allow your model to generate X future turns, and then you take whichever one is more right, backprop the positive weights. if they're just running that way longer to the point where they're exhausting the context window, forcing the model to again develop the summarization, and then they're feeding that into something else, that becomes a relatively difficult train time regime to be in. But if you have enough compute, in theory, you could just backprop through that whole thing, and like your GRPO policy would actually be looking at the group of all these different conversation
Right.
threads instead of just one conversation at one point in time.
And that seems really important for this kind of stuff because the issue with reinforcement learning is correctly attributing to each step of the reasoning process how important that step was to actually being able to solve the given task. So in this case, if you have a model that is doing self summarization in order to be able to effectively solve a task that requires it to pipe into itself a bunch of tokens, the model has to figure out what part of the summarization it's done correctly in order to solve that task, right? But it's this very long sort of horizon task that it has to be able to do, where it attributes, hey, this thing that I summarized at the very early part of my thinking process, that was actually really important to being able to solve this thing way later in my problem solving, pathway. So it's hard. It's really hard to solve this. I'm curious to see as models get better, what the upper bound for this is. Could you get to a world where you're having models self-summarizing up to a year's worth of history? Is that even feasible? Like how much context can you store in these summarization processes until you actually exhaust the available memory of the model?
Yeah, it's a really good question. I mean, can you maybe spend a little bit of time talking about these other approaches to memory in this way that maybe could happen once a conversation has otherwise been completed? If not text, what are the alternatives that we have, maybe more in vector space, to try to inject that context that you just gave the model into whatever the next conversation is? Like you're blowing away the KV cache. We're really starting a fresh conversation. What could you give the model if not text to try to warm it up to the context that you just gave it?
Yeah, so if you've ever trained a model, you might realize that you typically throw in tokens into the model that aren't actually text, like the beginning of sequence token or the end of sequence token. Some of the stuff has actually changed recently where we've actually stopped using some of these tokens, but back in the day, back in 2018,
In the olden times.
in the olden times, they would append to text certain special markers that would encode metadata almost about the text, where, one token might encode, hey, this is where the text starts, and then this is where the first series of text ends, and now I'm going to transition to talking about a different series of text or something like this, right? So people would add these meta tags basically into the model in order to, kind of like precondition it to expect a certain type of text. This was very common when you were mixing two different data sources together. If you were piping in Wikipedia articles and children books into the model at the same time, you might want to have some token that kind of delineates when one begins and when the other ends, right? So that the model doesn't really get confused as to why we went from talking about a Wikipedia article to talking about children's books, right? Anyway, so for a while, we've known that these tokens are really important, and folks have been trying to figure out, is there a way that we could learn tokens that basically represent the history of what's been said so far? So I think Lisa Lee with Percy wrote a paper in 2021. It was called Prefix Tuning. That was like pretty popular. And that was one of these first papers that was looking at sort of prompt tuning or how we can precondition a model to expect a certain type of context or a certain type of text. And here the idea was basically like if we could train some vector to encode some sort of a context or some sort of a history, then rather than feeding that whole history as just raw text to the model, we can just feed that one single vector into the model. And that'll do the same job as though if you had fed all this text to the model, right? So that kind of represents this larger piece of text. And more broadly, it's actually turned out that those sorts of approaches can be pretty effective. So folks have looked at things like attention sinks, where it actually turns out that you can have a token that actually sort of gobbles up a bunch of the surrounding context. And then that token you can then use to then represent everything about the context. And you can throw out the context and just have that one token serve as a representative token for the surrounding context that it saw. So all these approaches are interesting. More recently, folks have looked at different KV caching approaches so that you can, in real time, as you're going through the model in the KV cache itself has cached notions of context already, so that rather than having to see all of that, it basically has a cache of previous histories that it can just recall dynamically on the fly. And this you don't even have to do as an input that you pass into the model. Like as the model is processing the input, it can do this dynamically and decide when to look at history and when not to. So those are kind of like the types of approaches. I mean, frankly, for me, all of these things are very empirical. They're kind of like vibe-based approaches where people think, hey, wouldn't it make sense if we just had some sort of like a database that the model could read into? And how could we implement that? These things aren't very theoretical. There isn't much of a grounding in hard theory necessarily. A lot of it is just engineering approaches that people have discovered work pretty well.
Totally. And I feel like it's also kind of an acknowledgement that this, 1 to 2 million threshold, which is kind of the upper bound of even the longest context window models, are probably as long as companies really want to push them right now. I know specifically for the Gemini pricing structure, they actually price tokens differently depending on if you're in this lower than 200K regime and if you're in a larger than 200K regime. And you're starting to see that segmentation kind of across the board because the larger context that you have, actually past a certain length of model, the total amount of bytes that you have to store in memory allocated to the model become way disproportionately represented by the KV cache. It's like the KV cache even starts to dwarf the overall model architecture that has to be in memory. So I think that there's an element of this too, which is just companies saying, look, we would much rather try out different regimes that allow you to synthetically have a 10 million context window model instead of literally needing, attention accurate recall of those 1 million tokens, which I think is something we'll probably see more of once we agree that this is kind of the general scope of paradigm, but people still want longer context window models. I think there'll be a lot more clever approaches. And incidentally, a vector-based approach just seems like the right way to go to me, just in terms of what humans do, right? If you're ramping up to a new task, you probably can't specifically articulate all of the things that you've learned. It just is a little bit more of a vibe. You know where to go, You're like learning the structure of things instead of trying to make that super specific.
Yeah, and you can combine multiple approaches together. These things are completely orthogonal. Like you can have a really clever way of doing KV caching in addition to some prefix tuning thing, in addition to a summarization thing, right? These are all orthogonal approaches that you could combine in some way. And maybe that's the solution. Maybe you do that with reinforcement learning and you get a really good approach.
Yeah, I wouldn't be surprised. Well, we'll check it out in GPT Codex Max Pro 3.61 J7.
Yeah, exactly.
I love these names. Okay. Well, Richard, another big model that made waves this week, Gemini 3.0. I know you're very excited about this. The numbers look pretty solid. I think it's fair to say that Gemini is firmly in the frontier conversation now. This was available in the LLM arena for a couple of weeks before it was really made official that this was actually going to be a Gemini 3, which I think is always kind of funny. It's like these labs try a very rough pass to tell the model in its system prompt not to reveal that it's Gemini. But usually people manage to jailbreak those safeguards pretty quickly. And
yeah.
So, Richard, I know you played around pretty extensively with this model over the last couple of days. What are your first impression takeaways? What do you think? Is this exciting, or are they just benchmark hacking and there's really nothing here?
No, it's good, dude. It's really good. That's pretty much it. Okay. There's a couple things I want to highlight. So first of all, as always, we don't really know what this model is. But what we do probably know, and again, this is like with a maybe 60% certainty, is that this seems to be a very quick mixture of expert models. Like the latency on this model is very low, I found, especially compared to some of the older Sonnet models. When I compared it, for instance, with Sonnet 4.5, which has been my daily driver for the last month or so, it was solving really complicated tasks in maybe a quarter of the time. And I think a lot of this has to do with really good, clever routing mechanisms that they learn during pre-training. And I think this brings me to my first meta point, which is that for the first time, I think we are now talking about pre-training as foundational again. For the last 2 years, folks have felt that the thing that differentiates these different LLMs has been the post-training process, the procedures used to get these models aligned with human preferences. But Gemini, and if you ask anyone on the Gemini team, they'll talk about this, their secret sauce has been to really crack the pre-training regime so that when the model is learning for the first time on unsupervised data, it's somehow learning a good base model that can then be fine-tuned to an even better model. And they did this, I believe, by just training a really good, fast mixture of expert model. We don't know what this architecture is exactly. The reason we think it's a mixture of expert model is because those models tend to be the only way we can really do quick latency. So low latency happens because you're not really using all of the model. The model itself can selectively pick what parts of the model itself it wants to activate.
Because it's effectively like doing inference on a 32 billion parameter model, even if the
Exactly.
model knows the content of a trillion parameter model.
The idea with these mixture of expert models actually originated out of Google. So it kind of makes sense that they've been one of the pioneers of this. The idea is you have a base model, and this model gets to decide, usually towards the end, how many of its sort of like submodels or its experts it wants to route data to. So it can decide, hey, given this prompt, is this a hard task? Is this an easy task? And if it's a hard task, maybe I route it to more experts. I can get their POV on this and then I consolidate their answers. If it's an easy task, maybe I can just route it to a single expert, right? I mean, the metaphor is pretty clear. It's like, how many folks do I have to consult if it's a hard task? Probably more than if it's an easy task. And so here the idea is that you might also want to train experts that are specialized at certain tasks. So maybe one expert is specialized at translating things, another expert is specialized at summarizing things. And the model can then, at inference time, decide which experts to activate because it knows, hey, this one is really good at this task, this one is really good at this task, so I can route it dynamically. Most models these days, I think, are a mixture of expert models. If you were to look at Chat, if you were to look at Claude, it's almost certain at this point that everyone is using this just because these things are so efficient, they're so fast. And as consumers, we've gotten used to very low latency. So if you're not doing mixture of expert models and you're a big research lab, you're kind of shooting yourself in the foot. They have somehow figured out the trick to using a mixture of expert model effectively is to very carefully tune a lot of the hyperparameters of the model during training. And they've been able to do so very effectively. And frankly, man, I think that is really the big tagline here. It's like pre-training is back in. Gemini has shown that it's not just about post-training. You have to be really careful with some of the hyperparameters you pick. And if you spend enough time on it, you can get a really performant-based model.
I mean, I feel like one reason why companies have really switched to this dual framing of saying we have pre-training and then we have the post-training process is also because of data availability, where the curated data sets, what we think of as like these expert level tasks that you end up paying Scale or one of these other data layers to do, are usually introduced in the post-training side of things versus in the pre-training model, because the pre-trained tokens are just so dwarfed by the amount of tokens on the open internet, right? It's kind of hard, even if you have really high quality data, for to make that big of a difference in pre-training, or at least so the theory has been, right? So it's like the more the merrier. We're going to throw as much data as we possibly can at the pre-training phase. We're not going to be that selective, although we're maybe going to filter out things that are erroneous or really bad. But for the most part, we're going to focus our efforts on the post-training side of things and say, our best quality, our highest quality curated data sets from these PhD level experts, those are going to be what we aggressively fine tune on because we know that they're good, they're gold standard, yada, yada, yada. So is your theory in the pre-training side of things that this is a question of an algorithm regime? Like they actually have a better way, maybe doing curriculum learning or somehow learning scheduling? They have a better data set that they're throwing at these models, which also would be surprising because it's Google of all companies and they have access to a ton of data? Or is it something else? If you're trying to really peel back the curtain of what they're doing that's so unique in this pre-training, like where would you put your chips on the different approaches that you could do or experiment with to get a better pre-trained model right out of the gate?
Yeah, I would go curriculum learning and then I would go really careful tuning of the optimizer.
Mm.
Recently, a lot of my Twitter feed has been filled with folks writing blog posts detailing their experience playing around with like muon optimizers, for instance, and like the importance of very carefully picking hyperparameters for some of these newer generation of optimizers that have come out. When we were in school, everyone was using Atom W. I think folks still are using Atom just because it's fairly theoretically well grounded. There's this idea of momentum, and then you have kind of like a notion of the curvature a little bit of the loss function that you want to attend to as well, and how you're updating the weights. But models nowadays are often using optimizers that are substantially more complicated and complex than Atom W, and the selection of hyperparameters in these optimizers is very important. And broadly, I mean, this makes sense because the understanding is that in order to build a good optimizer, the optimizer has to have some understanding about the local curvature of the loss landscape. And you can't in practice ever actually compute that empirically. So instead, there's all these heuristics that optimizers use nowadays. Effectively, you have to compute the inverse of the Hessian. Okay, this is just whatever. This is a bunch of math. But the idea is there's this thing that's really hard to compute that these optimizers need to kind of approximate. And they're approximating it via these heuristics, but these heuristics, in order to get them right, you need all these careful hyperparameters that you set. So the selection of hyperparameters now for optimizers has actually become way more important than it was when we were in school. If you remember with Adam W, there's like two hyperparameters that you really have to set with Adam W, right?
Alpha, beta,
It's like
baby.
Alpha, beta, right? And alpha would be like 0.9 and beta would be like 0.99 or something like that, right? And no one ever changed those. It turns out nowadays you really do want to play with those hyperparameters and you want to be really careful with those. And then second, as you said, data curriculum is back in, baby. I mean, everyone's talking about data curriculum. This is especially important for super long context windows. So it turns out that if you want to train a model on a million sequence length context window, you have to be really careful in the amount of context that you feed early in training versus later in training. You tend to kind of want to do this like gradual increasing of the context window. So yeah, curriculum learning broadly has always been interesting, but now it seems like it's actually kind of paying dividends more than it used to. So those two things I think would be my guess if I had to say. Yeah, and then a lot of it is just engineering, frankly, being really careful with when the model fails and you have to restart it, picking like the right restarting point, picking the right checkpoints. All these things are so important.
I would love to do a back of the envelope math. I unfortunately have not done it for this podcast, but maybe we'll put in the show notes of if you actually took all of the videos on YouTube and then transformed them, had some LLM rewrite the transcript into a blog post or an article, like how much net new information you could get from the video over just the resources that are online. I don't know, but I do find myself just anecdotally often going to YouTube videos more now than I will to blog posts or other things that I found online. Like I feel like there's just more richness in YouTube videos. So I think there's also a chance that Google is just using more better data when it comes to doing the pre-training side of things. I'm sure there's a lot of algorithmic improvements that they've done as part of this too. There's always been such a built-in advantage within Google because of all of the properties that they already own, where their bread and butter is literally a data indexing company. And then their other bread and butter is YouTube, which is people publishing interesting videos where there's a continuous fire hose of new information of very high quality content. So I don't know. It's probably a question of just,
you're right. I think you're right.
All is better.
My feeling has been that, it feels to me like Claude, Chat, these models were trained on basically a bunch of stolen YouTube videos. I would love to figure out how much more data does YouTube and Google have that OpenAI and Anthropic don't have. Certainly they have more. I just don't know what order of magnitude that is,
Question.
But you must think that these companies all have roughly the same data. Maybe the trick here is that, Google with their world models that they've been coming out with has figured out some way to really, in a very good way, generate synthetic data that they can then train their models on. Maybe that's kind of part of the piece of the pie here that we're missing, or the piece of the puzzle that we're missing. But I don't know, man. Yeah, I think you're right. I mean, data is still really important, but honestly, man, I feel like a lot of it is the curriculum learning as well. The other thing we haven't spoken about is the fact that this model is sort of like native multimodal, you could almost call it, in the sense that when they are training this model, they basically don't train a separate image audio encoder. Like it's almost part of the same model. So the tokens that are fed into the model are the same regardless of if it's, video or audio or text. And doing this, I think, dovetails nicely with what you're saying, which is the fact that you can then very easily feed your model audio, video, text in the same higher level modality that encompasses all three of these without having to train these brittle separate encoders that kind of have to communicate with each other. That's always felt like a little brittle and very easy to introduce bugs into your approach if you do that. So yeah, maybe that's the trick. Maybe like the idea is that you just build a good model that can ingest all of the modalities, and that somehow then lets your model, learn some higher level semantics that span all these different modalities, and that's what lets it build this like really good knowledge of the world.
Well, Richard, that's a really good segue to Nano Banana, which, while by itself is not a multimodal model, is so freaking cool. So basically, Nano Banana was the code name for the image generation suite of Google's models. And then when they actually made them public, that was like the beta name. They actually made them public. They called them, Gemini image generator,
Right.
which is just way, way lamer, which is just,
Oh yeah, people just want to call it Nano
yeah.
Banana.
Nano Banana.
You gotta
was
give the
just
people what they
was
want.
so cheeky. So Google finally relented and seems like they're actually calling this Nano Banana in more public forms now. So they released Nano Banana Pro. It was like 2 days after the Gemini 3 release. They released this new image generation model. And this thing is really good. I mean, this thing is just astoundingly good. And I feel like we've often for a while now thought that image generation was just kind of solved. Like video generation is now the frontier where we're reaching this uncanny valley. But for the most part, we could generate really photorealistic images for some time now. What really blew me away with Nano Banana is it's the first model that I've seen that's really cracked the code on generating text in images, in addition to actually the visuals themselves. So like visuals are what they are, but I feel like pretty on par with, Midjourney or OpenAI's image generation model. But the text stuff, I mean, you can prompt the model just with text and you can say, generate me a billboard saying X, Y, and Z. You can give it a paragraph and it will generate pixel perfect rendering of the entire text that you put into the model.
It's amazing.
Which hasn't been done before. Like you usually would end up in a situation where, either like the kerning would look really weird, or sometimes, especially when letters got smaller, they would kind of fade into these ghost-like artifacts where if you kind of squinted, you could say this looks like there's text there, but it's not actually readable text. And I think, humans have such a high bar for what crisp text looks like that there's also some element of there where our expectations are just very higher versus a lot of images, especially if you're scanning through quickly. You're not really trying to read them pixel by pixel. With text, you often are.
Yeah, with that text, you actually need to read it.
Yeah, 100%. So Gemini seemingly cracked the code on this. It's just now in my mind generating compelling text and compelling visuals, right? Actually making diagrams, making, infographics. It's kind of a solved problem as far as I'm concerned. And it's so crazy to me that within one model release cycle, we really went from this seems like maybe this is just outside the capability or the scope of current architectures to really be able to do consistently to we're just fully done. It's a solved problem.
It's game over.
Game over.
We figured it out. We did it. Yeah. RIP OCR companies, right? It's kind of like, why do that anymore? We figured it out.
Yeah, totally. I mean, yeah, you can generate them, you can read them. Same model maybe can do both. It's crazy. I mean, I guess to make it a little bit more empirical and not just me fangirling, how do you feel like they really cracked the code on this? This feels like a goal that a lot of companies have had for some time, and it has just been elusive, which makes me think that it's very difficult. Like, do you have any even just loose speculation how they're actually doing this?
It feels like these models, the Gemini models in particular, have gotten good at figuring out where things are in a picture in a way that models before haven't been able to do. So we've talked about this before, Pierce, where one of your complaints with these models is that if you show them, a screenshot of your web browser and you say, hey, please edit, the button in the top right corner to not be blue, I want it actually to be purple. The model's going to say, okay, I gotcha, boss. But they won't really understand, okay, well, what is top right? Right. When they see the image, they're not seeing it in the same way that we are. They just see basically, process sort of like streams of bytes, basically.
Yeah.
And once you have that, it's kind of hard to go, okay, well, given the stream of bytes, this is what they mean by top right. They don't have that sense of geolocation that we do when we see, right? They don't actually see in the same way. Gemini 3, and we actually didn't talk about this, they were able to actually crack this new benchmark called Screen Spot Pro. Have you heard of this?
I saw it in the Gemini release, but up until then, no, I didn't know about it.
So it's a benchmark for locating elements on a screen. So it's actually basically what we've been talking about.
Yeah.
I didn't know this existed, but this is kind of cool. Models before that were getting somewhere in the like 5% to 10% range. So they were really bad. So if you asked it, hey, what's in the top left corner? 95% of the time, 95 times out of 100, it would just get it wrong. This model, Gemini 3, I think is getting it like 3/4 of the time right. So it's more right than it is wrong, and substantially so. That I think is very clearly linked to its ability to actually generate text perfectly.
Mm.
I think that there is a very strong correlation between having some sort of like spatial awareness of things and being able to generate pixels perfectly. Because think about it, like the issue with generating text well so far has been, as you said, that some of the text looks kind of fuzzy or we don't really know, like it kind of feels like some of the pixels like blend together. It's not really clear when one letter starts and when the other ends. Sometimes it'll just kind of fade into this ghost like appearance. But if the model has a good understanding of where things are, it can almost introspect and look at the text that's generated and say, oh, I can actually see the thing I built here, the thing I generated. It doesn't look very crisp. So let me actually try to do another iteration. Let me try to see if I can sharpen this up a little bit, right? That ability, I think, has been missing in models before because they fundamentally don't understand location. Like they don't have a sense of spatial reality. For whatever reason, this model, I think, is the first one that actually does, and they crack the code on that. And I said maybe that is because they're training on all these modalities at the same time, right? Like maybe the ability to actually be able to generate text correctly is contingent on you understanding the physical world well. And to understand the physical world well, you just have to train on petabytes of YouTube videos. So I would say it's probably a scaling thing at this point, combined with some, special googly special sauce, which might be something to do with the embeddings and how they represent this stuff. I mean, Google for a long time has been pretty good at this like vectorized search stuff, right? So they've been spending a lot of time in creating embeddings. So I imagine that they have some special way of like encoding image embeddings in some way. But that would be my guess.
I feel like after diffusion really came on the scene, people have then started to crack the code on transformers generating images as output as well. So I think there is a world in which they saw, hey, actually the train time saturation of learning that we can have with these diffusion models tops out at a certain point. The scaling laws just break down past some threshold. However, if you switch over to transformer architectures to generate this, it might be a little bit less efficient, but maybe we're actually able to saturate it with more data, and then it will learn more of these fine grained rendering techniques, which could actually be backed up by the fact that in Gemini Pro, you can choose the pixels that you want as output as part of this model. And I think the larger rendering just takes proportionally more time in order to complete. I don't know that for a fact, but that would maybe signal to me that if they have a certain tokens per second that they can generate as output and you are generating X more tokens as output, we probably could back prop that through and try to measure, okay, the differences of these things based on how it's generating and try to deduce the architecture from there. But I wouldn't be surprised if some amount of it performing better on the location tasks as well as this rendering is just generating a lot of data that has more of this numerical grounding. Because I really can't fathom a way that you would have a model be able to say, okay, the pixel coordinates 15, 132 correspond to this place
Right.
within the image, when the only representation that the model is getting of the image are these like segmented pixel regions, these like windows of maybe 50 pixels to 50 pixels, which then makes one token within this input. It feels like you kind of need some explicit training layer to say, okay, as part of the model internals, we need it to be aware of how these numbers correspond with the token inputs and like where
Yeah.
they typically
Yeah.
fall within this attention window. You need some stage of things in which you're correlating things to be a little bit more explicit, which to me would probably encourage them to just feed a lot more text examples through this generation. But whether it's exactly what they were doing before, a diffusion model, a transformer model, it'd be kind of fun to try to poke and prod a little bit from the outside as a black box to see if we could uncover telltale signs of one
Oh,
architecture
interesting.
versus another.
Yeah. Are there papers that talk about sort of little signs or little like spurious indicators that something is a diffusion model? I mean, there must be, right? There must be some sort of prodding that you can already do to figure out the latent behavior, if that latent behavior corresponds more to that of a diffusion model or a transformer model. If that kind of paper doesn't exist, it'd be really cool to do that sort of kind of research.
Maybe that is
Um,
actually the ultimate sign of AGI. The second that a model can accurately tell us how the model's built, we know something's
yeah,
going on.
right. Like a black box approach to
Yeah.
figuring out what kind of model it is. Yeah,
Self
super interesting.
introspective. Maybe last thing I'll say on this, Richard, but I mean, it does kind of feel like of all the big labs, the Google groups like out of DeepMind and Google Brain seem to have the most unique ability to just fully solve problems and
Yeah.
then move on to something else. I mean, they kind of did this with AlphaFold. Up until they released AlphaFold, people said, we think this is probably impossible. Or if it is tractable, it's certainly tractable only with a ton of computational and simulation resources that you throw at these protein folding tasks. And then Gemini just released AlphaFold, and people were like, oh, okay.
Oh, I guess we did
problem
that.
solved
Okay,
now.
cool. Yeah, let's move on. Yeah.
Totally. Or maybe more acutely, they released AlphaFold and people were like, whoa, this is pretty good. And then they released AlphaFold
Right.
2 and people were like, okay, now problem's really solved. It feels like this text generation thing. I mean, Nano Banana 1 got pretty close, but I said, okay, this still has so many failure modes. It's not really practical to spin up a product out of it because it just fails 75% of the time. This has succeeded in every single example that I've thrown to it, including the rendering of specific fonts. So actually asking the
that's so
model like,
cool.
hey,
Really?
generate me something in Times New Roman versus Arial. I'm sure it's not perfectly, like I'm sure that some typographic expert would probably look at them and say, the kerning on the letter J
Right.
is
Sure.
wrong. It's not what they intended. But to my layman non-typographic eyes, I'm like, yeah, this
looks
looks
perfect.
like the two different
Yeah.
fonts. I mean, totally.
Yeah.
Which also probably speaks to being context aware, at least vis-a-vis. They need to know what font correlates to what rendering and kerning. So there's definitely a little bit of explicit things that they're putting in this model.
There must be, right? I mean, they must be training some special like part of the model to be good at detecting fonts somehow. Google has a font library, right? Like they could just
So true. One thing that other countries might want of Google's that they're not currently getting, Richard, TPUs. The news item of note is that the US recently greenlit Nvidia chip exports to export the Blackwell series of chips to the UAE and Saudi Arabia. So this export control basically means that the US is greenlighting Nvidia to send 35,000 chips each to two state-backed entities, G42, which is based in the UAE, and Humane, which is based in Saudi Arabia.
Are these companies? What are these? Are these like VCs or?
These are companies.
Do you know?
Yeah, I think they're like
Companies?
data center
Okay.
providers, effectively. They can provide like,
Interesting.
kind of like CoreWeave in the US. I think it's kind of the local equivalent thereof. So, cluster of 35,000 Blackwell GPUs is a pretty compelling compute cluster to have in both.
It's like $1 billion, right? If you do the math. Yeah.
I think it's like exactly $1 billion. So Jessit Huang, no surprise, has been lobbying pretty hard for this, basically arguing that strict export controls were backfiring economically. They didn't really have a point. They weren't actually increasing US security objectives. So to maybe quickly recap the timeline here, this all started in the Biden administration in October 2023, where the Bureau of Industry and Security, which is a sick name, it's located within the Commerce Department. They rolled out successive rules tightening the sales of advanced GPUs to China and to other high-risk destinations. So this is kind of the department that is tasked with controlling all US-based exports. And if there's something that might affect national security, they can put some lids that require government exemptions to export these to countries that are flagged, basically. So they said, hey, we think these chips are getting too good. The AI race is really heating up. It's kind of around that era of that memo that was circulated about should we just be freezing AI development, whatever. So that was back in October 2023. And then in January 2025, they had more of a comprehensive approach, right? So instead of this one-off targeting to say, hey, we really don't want to export these to China and to some of these other countries, the AI diffusion framework was something that the whole administration came together in combination with the BIS to try to dictate, okay, here are the rules that we have. Here are the considerations that have to be made within the government when we're deciding what to export to. So they basically tiered countries in this different list of, friendliness to the US effectively, of, how risky do we think it is to go to this country and fall in the wrong hands. And it sketched out the framework for how you would do licensing agreements with different places. And they also added some export controls and certain closed weight models. So saying,
we weren't doing this before January 2025 on AI chips. This is the first set of regulations of its kind.
Well, so October 2023 was the first time when we put in these ad hoc rules, this comprehensive diffusion framework. In 2025 was, the first time that it was basically the time when it became industry or administration wide.
It's interesting that this wasn't a thing before, right? Because it's not like we haven't had really good chips relative to other countries in the past. It feels like there was sort of like a watershed moment, I guess, with the release of certain types of chips, maybe like the A100s, where people were like, wow, these are really much better than what other countries have for the first time.
It kind of feels like that's exactly what happened. That plus I think people started saying, oh, these chips aren't just being used for graphics acceleration or for like training pet models that help with search rankings. These things actually
Sure.
have
Yeah.
some qualities of intelligence or military applications that maybe people weren't really considering up to that date. Government's always a little slow, I think, to act on these things. But anyway, in 2025, people were saying, okay, great. There's at least a framework. People love their frameworks. And then in May 2025, the diffusion rule under the Trump administration was officially scrapped, with that same department, BIS, saying that it was too burdensome to actually institute in practice. So, in replacement of that, the administration basically substituted some tougher compliance guidance and then signaled that they would do more of these ad hoc deals with different countries and be assessed again on this per country basis. So that was a long wind up, but it's clear to me, and it's been clear for a while, I think, that there's this huge geopolitical competition going on. But I think specifically to this question of NVIDIA chipset exports, it's coming at such an interesting time in my mind because you see there being increasingly good chips coming out of China that are domestically produced and homegrown. And I'm curious just to think about it from kind of UAE and Saudi Arabia's perspective. Like they're trying to get these chips now, they're trying to lock them in. Is that to spur domestic industry of people training these chips? Is this to try to carve out? They want to make sure that they can serve chips that are probably open weight and trained abroad so that they can guarantee that they'll still have access to some of this, silicon based intelligence when we reach some stage versus just maybe waiting for Chinese chips to export because I'm sure they're not going to put the same kind of export controls on these things.
It's a hard question, dude. I think Saudi Arabia is legit about their interest in AI. I mean, I can tell you as an academic, I've been getting a lot of emails from the Saudi Arabian government trying to convince me to go to the MBZU. I think it's the Mohammed
Oh,
bin
yeah.
Zayed University. It's the first center of its kind in the Middle East. They've been getting a ton of funding. The idea here is to create a revolutionary AI institute in that part of the world. They're trying to bring world-class experts to Saudi Arabia. And man, they're offering a lot of money actually for academics to fly out there and create labs. As an academic, it's typically not the most profitable lifestyle. And these folks, the Saudi Arabian government is offering, top academics on the order of $500,000, something like that, 500 to $1 million to fly out there, create your own lab. I don't think you pay income tax. You really do keep that money. So it's effectively like a 30, 40%, bonus. Like really nice cushy housing, right? And more importantly, I mean, you get to create your own lab and have access to really good compute. That's part of the promise. I mean, the vision that they're selling here is look, universities in Europe and the US, they're competing with so many other schools and so many other companies for compute. Things are really expensive. We're going to make it really easy for you to just come out here and have all the compute you want. The only condition is you basically just set up shop here. You, as a professor, if you come here, we want you to attract really good students to come here. And then those students hopefully will stay here, create AI companies here. And we'll be able to, in 10, 15 years, create our own little version of Silicon Valley in Saudi Arabia. And kind of makes sense, man. I mean, if you've been keeping up with the news a little bit, it sounds like the Saudi wealth fund is running a little low on cash.
Which is kind of crazy because they started with what, like $5 trillion?
At this point, what the Saudi Arabian government is banking on is these giga projects that they're trying to establish. I don't know if you heard about this, but they're trying to build like a ski station in the southwestern part
Okay.
of the country. They're trying to build that like 100-kilometer long city. You know what I'm talking about?
Yeah, the
Like
line. I've definitely
the
done some
line.
reading on that. That's crazy.
So they have these giga architectural projects that are sort of reminiscent of China in the early 2000s when they were building out these massive, train station, airports, railway lines. In addition to that, I think Saudi Arabia's second part approach, their two-tier strategy, their two-pronged strategy, better said, is to also invest in businesses, industries that are sort of orthogonal to their oil. It makes sense that they would want to figure out a way to say, okay, well, can we future-proof ourselves and domestically build out this incredible AI industry, this AI boom that the US is profiting from? How can we basically domestically create and incubate our own version of that? And in order to do that, the first thing you got to do is you got to just buy a bunch of compute. You have to make it really easy for academics to be able to come to your country. You want to make it really easy for companies to be able to quickly access cheap compute. It's a way of effectively subsidizing the whole technological industry, right? That whole sector. And so I think it's very much in line with their, kind of like previous policies of trying to attract business. this is how you attract AI businesses by having the compute, right? It's not really a chicken or egg problem. I mean, it's like compute first and then anything else falls from that. So it makes sense, I think, that they're trying to buy the best compute, and the best compute just happens to be Nvidia. I don't think there's much more to it than that.
Yeah, and in theory, if it changes, they at least lock this in now. I think one of the things with these export controls is you actually don't know. It seems very ebb and flow of when you're going to get the green light to get these chips and when you're not. So
Right. It can be
they
pretty
probably
fickle,
just saw an
yeah.
opportunity.
Yeah.
Yeah. Now with this current administration, under this political climate, with this current iteration of chipsets, not many other countries are getting access to it. We think that we can because of our relationships with the administration. So we're going to send it now. And then, if China comes out with a new generation of chips that's better, we'll buy those too. Compute's kind of one of these funny things where I feel like it's more is better. You always want more chips. You can probably utilize those chips to do something, especially if you're trying to rent them out to other people. So, yeah, the question of constrained compute, I've always found one to be pretty fascinating because actually, to a certain scale of chips, if you're trying to do training jobs across these different architectures, it's not even that you can pay enough to get the chips. There actually are just times when you simply cannot have the chips available. Like, I remember this was a really big issue maybe a couple years ago, right before the NeurIPS deadline. Of I was trying to do one of these relatively large scale jobs. Probably, I mean,
Oh,
nothing
funny.
like
Yeah.
10,000 chips. But I was trying to maybe spin it up against like 64 chips, and
Mhm.
I literally could not find open chip capacity on any of the cloud providers. So I just couldn't do my training job because everyone else just had these running so that they could do the last minute training jobs to try to get their NeurIPS submission with all the different benchmarks. Not even if I said, I want to give you 2 times as much money as these are going for, they'd just be like, hey, sorry, we have pre-existing
We just
commitments with people
literally
that
don't
have these
have
chips. We
enough.
just literally do
Yeah.
not have the chips. So I think Saudi Arabia and the UAE, especially to try to attract researchers, that is such a huge boon that I feel like a lot of people don't understand, of just the ability to deploy your interesting research projects on a network or constellation of chips is often actually what researchers are looking for. Like, that is sometimes when people decide between this offer at OpenAI, Anthropic, or Google, it's whatever company is pre-offering them more compute resources. Because without the compute resources, you're just not going to be able to do your research and continue your career. If Saudi Arabia is saying, hey, no questions asked, you have access to as
Yep.
much compute as
Yep.
you need, I feel like even more than the $500K to $1 million, and maybe even more than your own lab, just the opportunity to do that is pretty compelling.
I think what they're trying to do is like the equivalent of a nice, shiny, new like house or a nice, shiny new car. You know, when you get into something that's new, if you've ever driven a new car and everything just kind of works perfectly. I think like they're basically trying to say, look, in countries in Europe and the United States, you guys might have the best technology currently. But the reality is that because of the red tape and the bureaucracy, it can be really hard to actually have this like seamless, streamlined research process. Oftentimes, there's a lot of political infighting to see which lab gets which chips first. I can tell you from firsthand experience, like that has been some of the struggles I had to deal with, where sometimes like we hear that the engineering folks actually got access to the new H100s and then you still have to wait a little bit. And it's because of like different priorities in the administration, blah, 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 right? Saudi Arabia is trying to say, you come here, you're not going to have any problems. Just, do your work here. Everything is just going to be perfect. It's going to be like a brand spanking new car where there's going to be no mechanical issues. You don't have to worry about anything. Everything is just seamless for you, right? And yeah, I think you're right. I think that is really appealing because it does sometimes feel like, even though we have good technology here, it can feel like you're kind of, things are kind of breaking left and right because other folks are trying to use the same resources. If you didn't have that and the experience of accessing compute was seamless, that would be amazing.
All right, Richard. Well, last thing on the docket for today, looking at why Cloudflare went down. So this actually might have been something that has even hit our listeners. It feels like more than half the internet was having issues last Wednesday.
That sucked.
Yeah, when Cloudflare went down. It was reminiscent a little bit about the Cloudstrike, different company, sounds similar, company outage that they had a year ago during the holidays when they actually shut down most airports because of a failed config deployment. The root cause is actually pretty similar. So Cloudflare had this automatic pipeline running to do bot detection on their website. And how a lot of these bot detection systems work is you'll have some fingerprint file that you basically upload that's, what is the signature of the bot or what is the signature of the attack. And you then are matching incoming traffic based off of those signatures. If they match the signatures, you block or you ask for a CAPTCHA. If they don't match, then you let them through. So it needs to
Okay.
update pretty rapidly as attackers are continuously updating their own things. Kind of this classic cat and mouse game that's on the internet. So what happened was there was some bug in the pipeline that generated these config file updates, actually outputted the fingerprints from some centralized database. So the file that was output as part of this was 2 times as large as the fingerprint file that came the day before. Like literally 2x. They like were duplicating these things one to one. So that then got picked up by their CI framework and deployed across all of their different compute things on the edge. Then an application level panic that basically had this assert. How like in Python, if you do an
Sure.
assert, something is true, and then it will just crash fully, no error
Right.
handling.
Right.
They basically had that in the very like first main part of their application boot up, where they'd say, okay, boot up the application, read this file, assert that it's, that it conforms to the schema. And because it didn't, instead of having some graceful error handling that would let the rest of Cloudflare operate properly, it just would crash the hosting software that would do the routing. So my read on this was it's basically like the proxy servers that they put in between clients and then your end server. Those were the ones that they have to also update with these files. And those are the things that went down based on a software level panic.
That makes sense. Well, that sucks. I mean, you would think that when you explain it so simply, it's one of these things where it's like, well, duh, just put in a little try and then little, catch it and then pass it. Their code must have been so bloated that this was one of those things that when they were doing unit testing, they just never thought to actually check, I assume. Because they probably didn't catch it. It was just like, there's like too many other things to test. And you just assume that this would never fail.
Yeah, I mean, I feel like there's a lot of software that kind of has that built in where just the assumptions that you think are pretty plausible to run, you don't want to handle those errors. It actually is maybe better to just loudly fail because you want to catch that issue. And like there is a precondition that you simply never would have expected. And that's kind of the idea with an assert in the most arbitrary case. It's like a condition that you're saying as the engineer of the software, I really haven't considered that this file is going to balloon 2x overnight. And therefore, something's probably wrong. So I generally want to crash it. It's obviously possible to make software that has none of those conditions where you've caught everything and handled even the most obscure of edge cases. I think I would probably argue that Cloudflare of all companies probably should have something like that in place. If something can happen across the trillions of connections that they serve each day, it probably will happen at some point in time. But I think it's only so easy to instrument applications that are robust to these internal systems level problems, where at the end of the day, it's almost like sending out a buggy update into your cluster of compute. It's like you had this bad config file, you're reading that in, you pushed out that file, so you trust that file, but the file actually was bad. And I do think that as we see more AI getting involved in the development workflow, I think things like this are probably bound to happen more frequently, where you're going to have some, artifact, some like production element that is written by some ML algo somewhere that outputs some file that like isn't quite conformant to the schema that you expect. And if you don't have the proper safeguards in place downstream, I think you're going to be in for a bad time. I think the ultimate solution to this sounds like something that's more in the CI/CD domain of like, there's just no world in which this system should have been architected so that one config file was deployed to all of their worldwide nodes instantaneously with no health checks to stop the rollout if something's wrong. And that's why these large sites are able to have such good uptime. Like Google, as far as I remember, has never gone down, like the homepage. Facebook, there are a few times, mostly with like DNS issues where they've come down, but otherwise it's been pretty solid. I feel like you just need to catch out an incremental rollout and say, if the metrics are looking bad when this rollout starts, we just have to pump the brakes immediately and roll
stop
back.
it, yeah.
To a good
that's
state.
why the internet is so cool. It's because it's okay for things to break because you can just reroute things around the broken parts of the system, right? It's like meant to be a brittle system, but like in its brittleness, it actually has like strength, right? The fact that there's like an infinite amount of ways that you could almost route traffic from London to San Francisco, even though a lot of that traffic might get dropped, that's okay, right? Because like you could just resend that and eventually it'll get to you, even if there is like some congestion or some parts of the nodes that are broken. So that's interesting. I mean, I thought you were going to say that the solution is just to write just try except clauses around your entire code base.
All over the place. Yeah.
Just your entire code. Exactly.
That's kind of what Erlang does. as like their core primitive. Like Erlang's
Oh,
kind
really?
of built on this idea that you have one supervisor that you're almost guaranteed is never going to go down, because every sub action that you write is spawned into this isolated sub process kind of a thing. I think it's like a virtual sub process. So even if that catches, the supervisor will see it and then just restart whatever failed.
Restart it.
So, the supervisor has to have very bullet tested code, but assuming that it does, then it's like you almost have try catches built in and a guarantee that the whole system's not going to go down. Even if like sub segments get into a crash loop, other things will still work fine. So yeah, part of it might just be a question of like, we need better languages. We need better deploy conventions. I think we're going to see a lot more tooling in that vein coming out soon.
Oh, yeah. I think
because
so too.
There's such an adjacent gold rush to the whole LLM and AI agents gold rush, which is what kind of tools can AI agents use to do better jobs? So I think there's going to be a lot of good developer tooling coming out, which benefits us. Like even if you're not writing AI code, even if you're not an AI agent, a lot of that tooling still helps us as well.
It's going to make your life easier.
Yeah, I think so
totally,
too.
dude.
So coming to a PR near you soon.
Hell yeah, dude. Well, I'm excited for it.
Yeah, nice, man. Me too. And in the meantime, enjoy the turkey or whatever the heck you're eating.
You too. Enjoy your tasty salmon, man.
I will. Trust me.
Yeah, I'm sure it's good. I feel like you guys are like your whole family's just like really good cooks. Am I crazy?
We like our food. Yeah.
I feel like you guys are like foodies. I think it'll be good.
Yeah.
Yeah.
It'll be delicious. I'll send you the spread.
Okay, please do, man. Well, send your folks a big hello for me. I'd love to see them soon.
Likewise.
I'll catch you after the weekend, man.
Till next pod.
All right, buddy.
Later, Rich.
Talk to you soon.
Bye.
Bye-bye.